Here we want to be able to solve and write the solution in interval notation. We have 4x divided by x minus 6, which is less than 1. If we took a look at step 1, it says write the inequality as one quotient on the left and a 0 on the right. Well, currently we don't have the 0 on the right. So what we're going to have to do is we're going to have to use some algebra to get that. So the first thing we want to do is we're going to subtract 1 to both sides. So this becomes 4x over x minus 6 minus 1, and then that's going to be greater than 0. Okay, and now what we need to do is we need to combine these two fractions. And what I mean by that is that we're going to have 4x over x minus 6. Okay, so what is the LCD between x minus 6 and then 1 over 1? Well, the LCD is going to be x minus 6. Because if we multiply the denominator by x minus 6, then we also need to multiply the numerator by x minus 6. So therefore, this becomes minus x minus 6. And therefore, it's going to be less than 0. Now what we want to do is we need to distribute this minus sign. So we got to remember to distribute it to both of those two terms. So therefore, in step 3, we have 4x minus x plus 6 in the numerator. And then we're going to divide that by x minus 6. Because that we have the common denominator, we can subtract then the numerators. So now if we combine like terms, knowing that now this is less than 0, we can get the following. We're going to get 3x plus 6 over x minus 6, and that's less than 0. And then if we wanted to go a little step further, we can factor out the 3, and we get x plus 2 over x minus 6, which is less than 0. Okay, so now that we've done that, now we need to go to step 2. We need to determine the critical points, and the points where the rational expression will be 0 or undefined. So what that means is, in order to find the critical points, we need to take a look at the numerator, which is 3 times x plus 2, and we're going to set that equal to 0. So we're going to solve for 0. So if we divide both sides by 3, then we have x plus 2, which is equal to 0, because 0 divided by 3 is 0. And then if we subtract 2 to both sides, we know that x is going to equal negative 2. So therefore, there's one of our critical points. And now we need to look at the denominator. So the denominator is x minus 6, and then we're going to set that equal to 0. If we solve for x, we add 6 to both sides. And therefore, remember that this makes this undefined. So therefore, this is a critical point, but this also tells us that in this scenario, that the 6 represents an undefined result. Now, in step 7, we're going to draw our number line. So we have our number line. We have our 0. Okay. And we know where our critical points are. We know one of our critical points is at negative 2. And then the other critical point is at 6. Okay. And now we're going to create our regions. So let's go ahead and do that. So we have a region that is divided through by the critical point negative 2. And then we have another region that goes through 6. So what we do now is we have region 1, we have region 2, and then we have region 3. And now what we're going to do is we're going to define what are the intervals for each region. So if we start here at negative infinity, okay, then it's going to go all the way to the value of negative 2. Now, negative 2 does not make it undefined, but you need to look at the inequality here. This says less than. It doesn't say less than or equal to. So because it says less than, then you're going to use a parenthesis. So therefore, this first interval goes from negative infinity to negative 2 with a parenthesis. And then our region 2 is going to have an interval that has a parenthesis at negative 2. And then we know that 6 is undefined, so it's going to have a parenthesis at 6 as well. So that interval goes from -2 to +6. And then we know that 6 is going to have a parenthesis going in this direction. It's going to positive infinity. So therefore, the third region goes from 6 to positive infinity. Okay, now what we want to do is we're going to test our regions. So for region number 1, we can pick a value in this region, so the next number lower than -2 is -3. So we have x is equal to -3. Now, you can either use, when you're testing this x value, the original, or what we got in step 5, where it's less than 0. It might be better to compare something that's less than 0 as opposed to less than 1, but it doesn't matter if you use the original one or step 5. I'm going to use step 5 because we're going to say 3 times x plus 2 over x minus 6. We want to determine if that's going to be less than 0. So we have 3 times -3 plus 2 all over -3 minus 6. Okay, so we have 3 times -3 plus 2, which is -1, so that's going to give us -3. And -3 minus 6 is -9. Well, that reduces to +1/3. So is a +1/3 less than 0? Well, that is false. So therefore, it's false in region number 1. Okay, let's go to region number 2. The easiest point that we can pick is 0, so we're going to let x equal 0. And then again, we're going to plug it into the inequality, 3 times x plus 2 over x minus 6. So this becomes 3 times 0 plus 2 over 0 minus 6. So 3 times 0 plus 2 is 2, so therefore we're going to get 6. 0 minus 6 is -6. That gives us -1, and we know that -1 is less than 0. So we say that it's true in region number 2. And then region number 3, we can pick the value to be 7. So again, if we use 3 times x plus 2 divided by x minus 6, we want to check and see if that's less than 0. So we have 3 times 7 plus 2 over 7 minus 6. So this is 7 plus 2, which is 9. 9 times 3 is 27. 7 minus 6 is 1. And so is 27 less than 0? Well, the answer to that is false. So we know it's false for region number 3. So now we can answer our question. We just need to know, okay, which intervals are they true? So if we take a look at region number 2, it is true, and that interval is -2 to 6. So we can say that our solution to this problem is the interval -2 to 6.